Good afternoon, everyone. Welcome. Good to see such a full crowd here in the auditorium, and also welcome to those of you who are joining us online this evening. It's great to see so many people interested in what we think will be a very informative conversation with some folks about a really important topic that you no doubt have been hearing a fair bit about as we talk about the science behind the right whale, the endangered right whales. And so some folks have said, not really sure why this is a science cafe. And I think it's important to understand our intent with the science cafes. I mean, certainly we want to shine a spotlight on some of the research that's happening here at the MDI Biolab, but we also like to take a look at some of these pressing issues that are affecting not only our local community, but certainly our world. And we like to look at those issues through the lens of science and try to shine a little bit of a scientific spotlight on those issues and help folks just be better informed about what the science says and be able to make your own decisions about your positions on those issues. So we recognize this is a sort of controversial topic, and we hope that you will participate in a way that is informative and allows others to be informed as well. And so with that, I'm just going to turn things directly over to my colleague, Fred Bever, who is going to introduce our panelists of experts this evening. We thank you all for being here with us and being willing to share your perspective on this issue. And welcome to all of you. So we look forward to a great conversation. Fred, thank you.
Thank you, Jerry. Thank you. So I just want to thank all of you for attending and everyone online as well. Also Cross Insurance for supporting our science cafes. I will add to what Jerry said that we also love to showcase and support other small but mighty research institutes like ours. And three of our guests here represent various aspects of that kind of scientific engagement and effort. So we're here to talk about what the science says about the North Atlantic right whale and why it's endangered and how it got there and where it might be going and some of the challenges in trying to both keep the species alive and also have positive outcomes for fishing communities as well. And these are the challenges that are faced every day by these sometimes conflicting species, us and the whales. And so first we have, right to my left is Amy Knowlton. She's a senior scientist at the New England Aquarium. She's worked for 40 years studying the North Atlantic right whale, much of it from Lubec here in Maine, from an NEAQ station there, because the whales used to head into the Bay of Fundy a lot. We'll hear more about why they don't or haven't been lately from Amy. She's been involved in all aspects of whale research, from their biology to attempts to try to create gear that's less harmful, and pretty much everything else. Nick Record is a senior research scientist at Bigelow Laboratories down in East Boothbay. He is a computational scientist, an ocean modeler, works with machine learning for predictive modeling around everything from algal blooms to whale presence, I think. Both of these guys are on the North Atlantic Right Whale Task Force. What is the formal name for it?
The Atlantic Large Whale Take Reduction Team.
The Large Whale Take Reduction Team,
Yeah.
Which is a federally convened group of stakeholders from all over the whale issue, from lobstermen to scientists to conservation groups to lawyers to regulators, and scientists have a big role in that. And then finally is Carla Gunther. She is the scientific director at the Maine Center for Coastal Fisheries, which is just down the road in Stonington. She has a degree in marine science and has been doing a lot of community engagement work from her position there in Stonington. And she's doing some work right now precisely around engaging lobstering communities and the greater community in these questions about our dual interests between human beings and whales. So first, Amy, and I'll just check with Roy in back. We doing all right, Roy, on the sound? Yep, we're doing great. I've been told that my voice tends to disappear sometimes, so don't be scared to like shout out if we're being too quiet. Let us know, but let's start with Amy, who's gonna give us a bit of a,
Clicker.
there you go.
Great. Thanks. And it's really great to be here and good to see this crowd. And yeah, I'm gonna try to cover a lot of territory in about 20 minutes, so or less. So we all have time to chat. But let's see. I'm gonna have to turn around here so I can see what I'm.
Mhm. There you go.
Okay, there we go. So this is a picture of a breaching right whale. That was up in the Bay of Fundy. And what I want to show you is sort of where right whales fit into the scheme of the large whale story. This represents not all the large whales seen in the North Atlantic, but quite a few that we would see out here. And right whales are really not as big as the fin and blue whales, but they're the girthiest whale of them all. They have a very thick blubber layer. And as I'm going to show you, they have a very different feeding regime than most of these other species. They also don't have a dorsal fin, so they're hard to see, but they're pretty cool species. Right whales are filter feeders, like all the baleen whales are here in the North Atlantic and throughout the world. But right whales feed not on fish and fast-moving species, but they feed on zooplankton, primarily copepods. And their feeding occurs wherever the plankton has aggregated in the water column. They form dense patches throughout the ocean. And as Nick will probably share more, right whales can hone in on that, and that's where they can be found feeding either at the surface or at depth. Now, I'm hoping this video will be able to show. I don't know if
This might not show well for our Zoom audience.
Anyway, this was just a video to show what a skim feeding right whale looks like. It's very slow moving, long baleen plates that really just are used to filter that plankton out of the water column. So
Amy, you once characterized it to me as, I think, this like a lawnmower going along the surface of the ocean.
Yeah, it is. Right whales are like the grazers, whereas other species are like the we call them the gulpers. You know, they have the big pleats, the ventral pleats, that when they take a big gulp of water full of fish or krill, and then they push that water out. Right whales don't have the ventral pleats like those other species. So they're just slowly meandering through the ocean in these patches, trying to catch plankton enough to sort of support their very girthy bodies. So it's quite a vision to see that. But anyway, I think you get a sense that from the previous picture, what that looks like. But what I want to talk about is why right whales are in the predicament they're in. They were hunted. They were hunted for a long, long time. They were found close to shore. We now dub them the urban whale because of that proximity to our industrial coastline. They're slow moving, as I mentioned, and often feed at the surface. And they yield large amounts of blubber and baleen, which were used historically, like the baleen was used like modern day plastics are now to create corset stays and buggy whips and umbrella stays. So really a valuable pre-industrial plastic type item. And then blubber, their thick blubber layer was used. They'd be flensed, and that blubber would be rendered down to create oil for oil lamps and for heating. So they were very valuable. So they were the preferred whale to hunt in that era. And they were hunted for nearly 1,000 years before they were protected in the 1930s because they were near extinction at that time. And their status at that time, we don't really know. We think it might have been close to a couple of dozen individuals surviving. And since that time, they've been closely monitored since really the 1980s, because we didn't there were so few of them prior to the 1980s that nobody really knew anything about them. So now that monitoring has been just broad scale and really helped us understand what is happening for this species. So it's a very collaborative effort between a lot of different research groups up and down the US coast and in Canada as well. It requires the input from all sorts of different expertise. So Nick here is, understands the plankton resource. Others understand, the hormones that whales produce. There's others that are collecting poop samples with the help of a scat sniffing dog to do that hormone work. There's collaborations with fishermen, acousticians, labs throughout the East Coast to help us understand the species. So it's been a really interesting collaboration, and that work is all sort of shared through the North Atlantic Right Whale Consortium. And I encourage you to go to that website, narwc.com, or maybe it's .org, to understand sort of all that has been learned about right whales, because there's a lot of resources and papers and information on that website. So one thing about right whales is that we can tell them apart relatively easily because their markings, their natural markings, which are like fingerprints, are on top of their head, which is different than humpbacks, where their natural markings to identify them are on the ventral side of their flukes. So you have to see them fluke to be able to get that identification. For right whales, unique markings, these areas of patches are called callosity. It's cornified skin that is formed on each right whale's head, but it forms a pattern much like a fingerprint. And that's what we use to catalog the individuals in this population. But right whales are in trouble. And I want to really focus on that today. And I think our conversation will touch on that. As I mentioned, they were hunted to near extinction, protected in the 1930s, slowly grew in population numbers until we peaked close to 500 in about 2010. But then since then, they've been in decline, and now they're only at about 360. The calving numbers, which are shown in the dark blue bars here, they've been very up and down. In 2018, we had 0 calves born, which was the first time we'd ever seen that in our 40 years. And you can see it just each year is quite variable and not as strong calving numbers as we should be seeing in a species that calves every 3 years or can calve every three years. They're delaying calving for a variety of reasons, and they're not getting pregnant at as young an age as they used to. So that's been a problem. But in the blue circles, those blue bars above, the light blue, is how many estimated mortalities we have determined based on the catalog work and based on analyses that sort of combine all the data about sightings and observations. And you can see that for the past decade, until maybe the past couple of years, things have been pretty dire. We're seeing for every carcass detected, there's probably 2 additional whales that have died that are not detected. So it's a big problem the species is facing. And in 2017, NOAA Fisheries declared an unusual mortality event because of this increasing rate of estimated mortalities and impacts that I'm going to show you a little more about. So yes, they are in big trouble. Just to give you a sense of where they live, as I mentioned, they're near coastal with their calving grounds are in the southeast US, foraging grounds from the mid-Atlantic northward up into the Gulf of St. Lawrence, and probably even further north than that, but that's where we're seeing the whales most of the time.
Amy, are they very social animals? Do the young are taken care of? They bond with the child, the mother and the child. How long to maturity? How long does it take to replace a mature animal?
So females stay with their calves for about a year, nursing that calf. The calf starts learning how to feed when they get north to the foraging grounds in the spring. But they're not able to sort of be on their own till like 11, 12 months of age. So it's a very long investment that females make in their calves. The age of first reproduction, the average used to be 9 to 10 years, but that is getting delayed because of some of the impacts we're seeing from both human activities and changes in prey
That was some
resources.
original science that you did, I think, on the delay in
I've been
calving age.
part of a study on that. Yeah.
So why is there a slowdown in birth rates and maturity for being able to have a child?
Well, I think there's a number of reasons, and I'll touch on that in some of the slides later, but it's really related to the human impacts they're dealing with. And also the changing food resources in relation to climate change. So that it's just taking them, they're adapting to climate change, but the other human impacts are having a greater effect than they ever used to.
So maybe I'm wondering if we should talk now about one of those adaptations to climate change, which is movement,
Mhm.
places where they haven't been before, and maybe bring Nick into the conversation at this point. So Nick, you've done a lot of work trying to understand what's going on with their forage food. Is that right?
Yeah,
So tell us about that. Tell us about that work.
sure. Well, Amy had a picture slide or two ago of a copepod and a jar of copepods, I believe. There's one right there, and there's a jar of them. If you put a net, plankton net in the water off the shores of Maine, you'll come up full of copepods. Or another way to think about it is, has anyone here swum in the ocean? Less than I would have thought, but okay. You're here on MDI in the coast of Maine. I guess it's cold. But so those of you who raised your hands, you've probably, just like the North Atlantic right whale, swallowed copepods. But they're really small. They're like the size of fleas. Some people say like a grain of rice, but they're really smaller than that. And so you have to imagine you're a mother right whale. You have to eat thousands of pounds of these every day, especially if you're growing a calf inside you or nursing a calf. So there's a really heavy food requirement for right whales. And so there are really special places that they have to go to eat. And what sets up those special places is a number of conditions have to be there. So you have to have a lot of phytoplankton, that's like the photosynthesis that happens in the ocean that the copepods eat. So you have to have basically really productive waters. The Gulf of Maine is some of the most productive waters in the world for various reasons. And then you have to have oceanographic currents that will concentrate the copepods together in patches that are dense enough for right whales to get something out of spending their time doing this lawnmower pattern, slurping them up. Because if they're spending more energy than they're getting, like if the copepods are too thin, then it's not worth it for them to be there. And they'll go look for foraging areas somewhere else. And so up until about 2010 or so, where you had that nice time series plot when the mortality started. So up until around 2010, pretty much year after year, right whales would follow the same patterns. I wouldn't be surprised if you have a slide that shows this in a sec, but where they would go to the same places every year to feed, and it would follow the timing of when copepods would be there in dense patches that they could feed on. And as part of the take reduction team, there have been these measures that have come out of that to help protect them in those places. And I would say that was one of the reasons that right whales were recovering over the first part of the 2000s. And then around 2010, there were these, you probably heard that the Gulf of Maine is warming faster than 99% of the ocean and that sort of thing. That all started around 2010 when there were these big oceanographic shifts. And I have a couple of slides that show where those currents are.
I wonder if we can get to them.
If we don't, that's okay.
How many slides do you have left?
Well, I have a few slides just showing the human impacts of right whales.
I'm just wondering if we can.
Well, I'll wrap up this part, and maybe if we get to them, I can.
Unless you want me to scroll forward.
Well, that's what I was wondering, if we could scroll forward.
Oh, do you want me to?
Either way. I mean, the take home is those currents shifted pretty quickly, and it moved that the places where copepods aggregate got moved. And the right whales took them a while to figure it out, and they were going to places where those protective measures were not in place. And that led to a lot of the mortalities that you see in this graph.
So, and basically they had been going to the Bay of Fundy a lot, which is where Amy would study them off of Blueback. But then they shifted and they started, I mean, I know we don't know exactly what route they took, but they started bypassing their usual routes along the Maine coast and went up into the Gulf of St. Lawrence. And that's where we've been finding them more. And, you know, there were shipping patterns there that they weren't used to, trying to avoid whales, right? So, you know, why did that shift coincide with the mortality events? Why did that was change in climate and change in habits, change in abundance of these tiny copepods? Why did it mean a tougher time for the whales? Why couldn't they just follow them? No problem.
I mean, I think we spend so much energy focusing on these areas where we knew they were going to show up again and again. And like, I think a lot of climate changes are going to be, it's rapid and sort of takes you off guard. It can be a surprise, you know, just like the storms on the coast this summer. We know sea level is rising, but when it suddenly shows up at your front door, it's a surprise. And I think it's that same mentality. We sort of view things as changing slowly. And then when they do change suddenly, like they often do, we're caught on our back foot. And I think that's kind of what happened with the whales.
Yeah. And I think because they're shifting their distribution, they're facing more exposure to fishing activity, shipping activity, areas, like you said, that aren't managed. Although Canada has done a lot to try and manage the situation up there. So, but it's just a sort of, like Nick said, we got caught off guard, and right whales started dying at a very high rate, and it really set them back quite a bit. So,
but the flip side of that is, I think it implicitly shows that we have the tools to be successful, because as soon as they moved out of those areas that had been protected, that's when the mortality started. So I think it's, you know, it kind of shows that there is the potential to do things right.
yeah. And maybe I can show some of the, what we've been seeing from the human activities, the human impacts. Let me go back. So the two threats that right whales are facing are vessel strikes and entanglements. And I'll touch quickly on vessel strikes. It's been a pretty bad year so far for vessel struck whales. We've had 3 deaths, including of a female with a dependent calf this winter off the mid-Atlantic and Southeast US. This calf was a newborn calf of Juneau, struck sometime like a month or 2 after his birth. And we determined, based on a forensic assessment of those cuts, that it was probably a vessel in the 35 to 60 foot size range. So not a big vessel. So, and those vessel sizes are not managed presently. Now, what we do is we monitor the species to look for evidence of these cuts, propeller cuts, or if it's a carcass, it's flens to the bone to determine if there's broken bones that would be caused by blunt force trauma. And so we categorize them into severity levels. And what I just want to show here is what has been happening since the late 70s. We're seeing vessel strike mortalities in nearly every year, or vessel strikes, some resulting in mortality in most years. So it's not been a good situation. And we know that even if they do survive the initial strike, that it's going to reduce their health, affect their reproduction, and sometimes survival, especially if it's shallow or deep cuts. Not the superficial ones don't seem to have a negative effect. So it's not been good for this effort, and more needs to change. Here in the US, where we're trying to put it, NOAA is trying to put in the regulation to address the threat here. It's been a bit challenging. But what you can see here, the dashed lines represent an existing speed rule. Vessels have to go 10 knots or less in those areas with the semicircles and the rectangles that you can see up and down the coast. What NOAA is proposing, though, is to expand those areas because those have not been adequate to address the threat. So they want to expand it out further from shore, include vessels down to 35 feet in length, and make any dynamic areas that are presently voluntary to make those mandatory, because we know that the voluntary measures have not been effective either. But there's been a lot of pushback, and right now there's a bill put forward by Buddy Carter from Georgia, who wants to actually delay this rule from going into place until 2030. He feels that technology needs to be developed and implemented, but I've been around here for working on this for 40 years, and technology is not going to be a simple fix, and it's not going to I worry that it's not going to be successful. And if it is successful, it's going to take years to develop and really make it work and to get it in place for vessels. So it may be a tool that's useful for some of the smaller vessels, but again, it's going to take time and that right whales do not have. So there's going to be a congressional hearing on this on Thursday morning at 9:30 if you're interested in listening in. Usually it's the House Committee on Natural Resources, and my colleague Jessica Redfern will be testifying as part of that. So just basically share that the technology, yes, maybe it can be developed and could be useful, but it should not delay the rule for another 6 years. So on to entanglement. This is a whale named Snow Cone, which was in the news for a while, and unfortunately she did not survive her 2 entanglements, but just to give you a sense, again, we collate the severity of the injuries that we see on right whales. And this is a graph showing how many we've detected since 1980, over 1,800 entanglement events. The majority of them are determined by the presence of scars and not actually carrying gear, showing that the whale got entangled, somehow managed to escape it, and sometimes with severe injuries as a result. So what we're very concerned about is that this increase in moderate and severe injuries in the recent 15 years or so is really what has, we think, added to the decline that we're seeing in this recent decade. So it's a lot of entanglements out there. Many of them do survive it and with the minor injuries only, but a lot do not. And that's a concern. And just as a graphic that you can find online, this is part of the unusual mortality event. 139 cases are in this event right now since 2017 to the present that have been impacted negatively by these vessel strikes and entanglements. So it's just sort of this chronic problem that right whales are facing. So I wanted to touch on why, through my research, why I think this is happening. One of the things that I learned is that rope strengths have increased dramatically over the decades. You know, we didn't have plastic ropes until basically the 1950s. And then in the early 1990s, a rope manufacturing change resulted in a copolymer fiber that's nearly twice as strong as the old polypropylene ropes. So we have strengthening ropes. We also have a major increase in fishing effort. This is showing lobster fishing in the Northeast, from mid-Atlantic through the Northeast from 1967 to 2014. And you can see a very dramatic increase in effort and also a shift of effort further offshore, which makes the fishing activity overlap more with the whales that typically live, with right whales that typically live further offshore. Just to give you a sense of how much that change is, so Maine DMR does a great job at monitoring annual trap tags that they allocate to the fishing industry. And prior to 54, there was just about 500,000 that were allocated. And that crept up to, by 1999, 3 million trap tags have been allocated in Maine. And that's remained about that level to the present. So it's just a really dramatic increase. And this same pattern is similar in Canada. A lot of increase in fishing effort.
I wonder if at this point we could bring in Erin Summers, she's joined us by Zoom. She is the director of marine mammal research at the Department of Marine Resources. And they're now doing a lot more surveillance and monitoring. And I think if we're able to bring her up, maybe she could tell us a little bit about what DMR knows, what it wants to know, and what it's doing to get to know.
Hi, can you hear me?
Yes, we can.
Hi, Amy, how are you?
Good, how you doing, Erin?
Good. Sure. Just to touch on what Amy just brought up as well, the number 3 million is the number of trap tags that we sell in a year. Not necessarily tracking the number of trap tags that are in the water at any given time, which varies dramatically across the year. So a lot less in the winter time versus the summer when the fishery ramps up inshore. And also not 3 million all at once. We have also, in terms of the fishing effort, started doing a lot more tracking of the fishery. So we have some efforts in terms of 100% harvester reporting that has been required for the first year last year, where lobster fishermen are required to report where they're fishing. And we're also implementing the federal tracking program, which is a little bit tied up in federal lawsuits right now, but the federal vessels are, as of this year, currently required to carry trackers as well. So we'll have a lot better look at the fishing footprint and how that fishing footprint overlaps in time and space with where we think right whales are in the Gulf of Maine. Brett also mentioned that we have a lot of other monitoring programs. So we've been spinning up some new research in the last year and a half. So we have a large passive acoustic monitoring program now where we have 26 sites that are basically listening for right whale vocalizations across the entire Gulf of Maine out into Canadian waters as well, and up to the Canadian border by the Bay of Fundy. So looking at some of those habitats that they used to use previously and also inshore where they have overlap with the fishery. As of this month, we have also started monthly vessel-based and aerial-based visual sighting surveys for right whales across the entire Gulf of Maine. So heading out in boats and planes, doing visual surveys for right whales and documenting other wildlife, and doing some plankton sampling along that route as well. And some other collaborations that we have actually with Nick and others to do some modeling work with integrating all of those data sets, looking at different risk assessment tools that we can use to inform the management decisions that we'll have to make when we're talking about regulating the fishing industry to bring down the risk of entanglement for right whales coming towards 2028, 2029, when that will be required again.
So Aaron, so you're getting a lot more information because just recently 2 programs were enacted. One requiring 100% reporting of trips by the lobster fleet, right?
Yep.
And then the other is that federally licensed lobstermen they have some sort of recording device, video recording device on their ships. What's the uptake? What's the compliance? Are you getting more information? Is it coming in? Are you finding it useful yet? Is it still too early?
It's a bit early. We're like auditing the harvester reporting data, but they're in compliance with that. We've been getting really good data from the trackers that the vessel trackers that we have in the federal fleet so far. We haven't been able to like compile that data and look at it to a large degree because of there are some like pending lawsuits around privacy with that data that are pending. So can't talk a lot about that, but yeah, that will be kind of a game changer in terms of being able to look at the footprint of the fishery and how it overlaps with right whales, and then use that information to try and build some models that can hopefully potentially look forward and forecast a bit how the risk might change in the Gulf of Maine over the next coming years, and sort of tailor our management efforts to provide the best conservation for right whales and also minimize the impact for the fishing fleet.
So that brings up questions I'd like to ask Nick about predictive modeling. But first, I think maybe we should go to the audience. And if there's anyone online who's got a question, wants a clarification, Sharon and Jerry, do we have a few?
I do.
Okay.
So can you hear me? Roy.
Roy.
Oh, there we go. All right. So there is a clarifying comment. Someone says it's their understanding that scientists surmise that the right whales have changed their major feeding field from the Bay of Fundy to the Gulf of St. Lawrence because the cocoa pod shifted.
Sure, that sounds like a question for me, I guess. I mean, that's one shift that's happened during the kind of August, September time of year. And I would say like it's true, but with a couple of caveats. So one, there are other shifts that have happened other times of year. So for example, in the kind of late winter and spring, there's been a shift more to toward the southwest. So it's not like everything is just moving north. And there's like south of New England, there's some feeding areas where whales have found good enough, I guess, copepod aggregations that they've been aggregating there. The other thing I'll say is you just have to be a little careful with the language, because when people say, oh, whales have left the Bay of Fundy, now they're in the Gulf of St. Lawrence, it makes you think that that's a done deal. But it's not like the climate's done changing. You know, we haven't settled on our new climate yet. And, you know, even within that, there's a lot of year-to-year changes. So this year, for example, the deep waters in the Gulf of Maine are colder and fresher than they've been since before 2010. And there's a lot of reports of high copepod concentrations already this summer in some of the waters that we think of right whales having left. So it's not to say that there couldn't be a year or two where they revisit those feeding areas that we think of them having left. I mean, the long-term trajectory of climate is probably that the Gulf of Maine will not be good for the types of copepods that right whales like, but we're not there yet, and the climate is still changing both in the long term and on a highly variable year-to-year basis. So just want to give those words of caution. But yeah, in general, yeah, that's kind of captures one of the main shifts that have happened.
But just one anecdote to add to that. Just earlier this month, there was a detection of about 30 right whales off of Virginia, which is a really unusual time of year, from my understanding, for them to be aggregating. They were quite far offshore, and you know, so it's just interesting. It's sort of they are starting to use places that we might not expect them to use. So
I think you have to think about it a lot like how humans are adapting to climate change. You know, there are places where suddenly a place goes into drought for many years and people have to abandon it or things like that. And or forest fires or, you know, what have you. And I think there's something like, I don't remember the numbers, but millions of climate refugees per year now, something like that. And, you know, it's not too different from the whales. There are environments being upended and they're going to be trying to figure it out just like we are.
Got members of the audience, please, sir.
Up in the Gulf of St. Lawrence, when the unusual mortality event took place, there was something like 31 or 34 whales killed up there in 3 years. Or if you go to 2015 was the first episode where 3 white whales were killed. And from then on, it went downhill. Except there wasn't any in 2016 and there wasn't any deaths in 2018 because the whales moved north and south a little bit. But out of those 31 whales, 7 of them were unknown. They'd never been seen before or registered, not named or registered. And they were in fairly good condition that they should have been able to tell. That represented 21% of 500, which is about 130 whales unknown. So we don't know where all the whales are, apparently, because there's 130 that we don't know where they come from, or when they come in, or when they go out, or where they're going. I mean, where are all 400?
So your question for people who are on Zoom who can't hear you, your question is, well, how do we know there are more whales that we don't know about?
Yes, it's kind of a proof that there is a lot of whales that we don't know where they are. And I know the TRT team, it says the same thing. I've been told that we really don't know where all the whales are, but we have to go on what we see. And what is seen and proven is the births and the deaths, which was the report card method of keeping count of the whales for decades until the mortality event came up.
But what is your question, sir?
My question is, I want to proclaim that there's victory. Like you said, we have taken the course and we have corrected the problem up there in Canada. Canada shut off that lane and ships lane was still in the middle. They were all cruise ships. And it took care of the crabs deaths, which was a heavy crab year that was being hauled down off the Cape. It whales dying from crab gear. There was no lobster thing. My question is, are we gonna quit going after the lobstermen because they show no sign of being involved in this?
Okay, now we've opened up a big field of conversation, which is you're trying to say, do we really think the lobster fishery is a big problem here or not? It's speaking.
No, my opinion is.
There's
they
more
should
whales
be
out there that are unknown. So this is the gnarliest area of this question that there is the conflict between lobster and gear, which is rope in the water, and where the whales are going, and where they might be going. And part of the solution for these two species to live together is going to, it appears, mean changes in gear. And I want to ask Aaron first, Aaron Summers at Department of Marine Resources. It's something you guys are planning for, I think, that there's going to be governmental action that will require, in some circumstances in the Gulf of Maine, changes in gear. And you're gathering data in order to inform, as best as you can, those decisions about where and when that should happen. Is that a fair sort of characterization of what the department's mission is in this case?
Yeah, I think I would spin it a little bit and say that I think that part of what the upcoming regulations might include will be some additional time area management of where like the fishing gear and right whales overlap. So those areas of really high or moderate risk of entanglement. So part of our data collection on the right whale side is, and on the fisheries footprint side, is like determining where those areas of overlap for risk are occurring so that we can target the fishery in those areas more surgically than having broad-based management that affects a lot of people. That being said, the tool to protect whales in that scape is more about the closure of fishing gear, of fishing area to vertical lines, and not necessarily the mandate of the type of gear you would be able to use. So I think the difference in what you're saying and what I'm saying is, will we be mandating the use of something like on-demand fishing gear? No. Is it a tool that fishermen could use to access areas that they might lose access to? Yes, if that makes sense.
Your point's well taken. It's outcome driven rather than.
Yeah, so the tool for whales is the closure. The tool for fishermen to access ground that they have lost is potentially on-demand, alternative, or ropeless type fishing gear.
And so now we have an opportunity to bring in Carla Gunther, who is working with the Department of Marine Resources around this question of whether gear changes can be part of the solution. How do you engage lobstering communities in that effort? So Carla, maybe you could tell us a little bit about what you're doing there in Stonington around this issue, both in terms of the actual gear, but also you've got another project that's really about community engagement. If you could tell us about those.
Sure, thank you. Thank you, Aaron, for paving the way. So we have the National Fish and Wildlife Foundation came up with some congressional money to basically address some of these challenges and to figure out how we could be having a coexisting lobster fishery and study and learn more about the right whale. So with the Department of Marine Resources, we're a gear library. There's a couple other locations up and down the coast of Maine where we're recruiting some fishermen to trial various types of gear to find out how it would work and get the risk associated, the changes to how a fisherman would operate his vessel, his or her vessel, and other impacts to their fishing business by using the different gear types. And that just started and we're just kicking it off. We currently in Stonington don't have a fisherman that's participating in the gear library yet. And then we have another project that we have a direct award from National Fish and Wildlife Foundation to do this community engagement, and recognizing that in a large part, the fishing community, despite participation in the TRT, wasn't brought along with a lot of the information along with, while we're learning about right whales, all the changes, much of like what this gentleman here was showing, like we're grasping at information in certain ways. We are understanding and interpreting our information, but I don't think, other than the people closest to it, don't really understand all the different data sources and how to reconcile all these different pieces of data. I think that's why a lot of you are here today and tonight on Zoom, is like, okay, I'm reading all this stuff, but how do I reconcile it and really kind of see through all of the different messaging? And I think our fishing communities are highly dependent on this. And I'll just say, you know, it's a comment that Erin and I had 2 years ago in putting these proposals together. Our community in Stonington Deer Isle, it's the largest lobster port in Maine, where about 3,000 fishermen or fishing families live there year round. We have a school that we're trying to figure out what to do with it. And when it came to passing school budgets, the main thing was, we don't know if we can hire an administrator, a second administrator, because we don't know if fishing is going to be around. And so there's some major climate change resilience investments in working waterfront from our storms this past January. A lot of places, these whole communities, not just the fishing industry, but the community that relies on the fishing industry to bring in money over the dock really is grappling. And we're talking about a lot of communities that don't even have a town manager. You have a select board, and the select board are all, you know, wearing hats, doing highly varied things. So being able to chew through all this information and understand what it means for really like pivotal impacts to our communities is where we are coming in. So we're just starting. We have a long history of working with the town of Stonington. And I'll just introduce Molly Miller here in the front. We've just hired her to work on this project. She lives in Vinyl Haven. And so we're starting to communicate and engage these several, you know, basically the top fishing ports in the state, really to understand how do we do this. And fishermen have felt alone. They have felt persecuted to some degree in this situation. And so there are community members, your well-intentioned summer resident who has a local fisherman helping kind of deploy his docks or whatever, and getting an earful. How do we support the fishing industry? What does this mean? And so that we're also trying to get that support, let fishermen know that their community supports them, and let fishermen know that there are solutions. There may be, you know, a retired engineer in the population of some of these communities that can really help guys, you know, figure stuff out.
We have some audience questions, and hold on just a second.
That I see up here is all about where there's lobster fishing, but the pictures you showed us appeared to be strikes by big ships. And I'm trying to understand if most of the damage is done by the bow or the propellers on the big ships. What damage is done to the lobster fishing?
So the question is, what's the difference between the damage that a ship strike can do, or that an entanglement with lobster gear can do? And I think inherent in that is also, what's the proportion here? Amy, you probably have some slides on this at this point, or
Yes.
some information.
See here.
Particularly that question, as you know, how is it ship
proportion.
strikes? Is it entanglements?
It's really both. And let me go back a bit, because the unusual mortality event that's been going on since 2017, as you'll see, at the top we have 9 entanglement deaths and 15 vessel strike deaths. We have 30 entanglements that are seriously injured and 3 vessel strikes seriously injured. And then under this injured and poor health, 49 entanglements and 5 vessel strikes. So we keep a really careful tabs on what these whales are experiencing. And yes, vessel strikes have been a big problem. And, you know, I showed that picture of that young calf that had been struck by a pretty small vessel, actually. But entanglements are also a major threat. You know, we had this case in just this January of a right whale that was found on Martha's Vineyard that had been carrying gear for a couple of years around its tail, became very embedded, and it was linked back to main gear through the gear marking. So to get to this gentleman's point, I think any rope is a threat to right whales, and sometimes it's the heavier gear is the bigger concern, because especially the older whales can't get out of the thicker gear, but the young whales can't get out of the smaller gear, the less riskier gear. But I can talk to you a little bit about some of the solutions about entanglements, some of the research we've done to look at rope strength in relation to entanglements, because it is one of the solutions that has been put out there to some degree.
Carla, let me ask you, I know that several years ago, Aaron, for instance, was working on breakaway rope, breakaway links, which Amy's done a lot of work on, trying to figure out what kind of breakaway you need for a whale to be able to get through it. Is that still in the mix now, or is it, with your gear library, will it include these kinds of
The
solutions?
gear library, as far as I've been told, does not include anything more. I mean, we already put into regulation the weak links. We put into regulation several things. There were some other like rope cutters upon a certain
these are the links.
pressure, tension strength that they would cut the rope and things like that. But they implemented weak links already in the fishery a couple of years ago as a requirement when they also did the main gear marking. But I think right now the gear library is primarily around reducing rope in the water column. So it's either called on-demand gear, where you can kind of remotely trigger a buoy or some other system to sort of lift the trap to the surface. And so there's no,
I have a picture of that.
There you go.
yeah, there's no static kind of rope from the trap to the surface of the water. There's also no marking of the trap from the surface. So that is a big challenge for the lobster fishery to figure out how to do this. And it's not just lobster fishermen or lobster fishermen. There's also mobile gear. There's the scallop fishery. There's the ground fish draggers in the western part of the state. So there's other gear types that really need to know where gear is sitting on the bottom. And then the other is this it's called a pop-up gear or timed release gear, where you can set a tension in a spring, or you can set a timer. And so 42 hours from now, I'm a summer fisherman, I'm fishing, I know every other day I'm rotating through my gear. I'm gonna set this thing to pop up 48 hours from now. And that is being tested in the gear library, both the tension release or the spring release and the time release. I do know of some fishermen in Stonington and Deer Isle who have been working with the on-demand gear, and that on-demand gear, a lot of fishermen are afraid of it. It's very expensive. The time release gear, the pop-up gear, is much less expensive per unit. So there's a big question about sort of the equity involved in who then it changes the dynamic, that financial investment of being able to participate in the fishery. And by and large, Maine it is still an owner-operator fishery, which requires the owner of the vessel to be on the boat every single day. We are not largely, despite some of the size of the boats you see out there, it doesn't compare to what you see in Gloucester and New Bedford. We are not a largely capitalized fishery. And so talking about, large investments to be able to go out and make money during the prime of the year is a huge concern. And it's a concern for the department as well, to think about the equity issues involved and how you require the access to such expensive equipment to be able to access the resource when it's most abundant.
When you do this community engagement process, are you bringing some of the principles of social science to bear? Are there metrics? Like, what's involved? I mean, because it's hard for the scientists and the fishing community to really understand each other well, or it can be. And what kind of tools do you have with this work that you're going to be doing?
Well, those are great questions. And largely it's the role of our organization, Maine Center for Coastal Fisheries. We are a boundary spanning organization. We were founded by a former commissioner of marine resources over 24 years ago or something. And so it was this recognizing this gap between management, science, and fishermen, and being able to facilitate more and more of that conversation. One where you're actually generating research questions from fishermen who are really interested in preserving the resource and curiosities they see while they're on the boat. And then others is pairing up the academic researchers with fishermen so that they can kind of jointly pursue a question. And so I think that's kind of where we are with the whale situation here. And we have it's called Community Fisheries Action Roundtable. It's a methodology we've been using to basically get fishermen talking about their observations and get broader community members talking about their concerns and their observations and coming at it, because regulators and scientists come at it with their, I'll say narrow view in this sense. And then fishermen also have their narrow view. And then just sort of to get those narrow views broadened by sitting at a table together is really, really important, because the solutions often are found by just expanding those windows a little bit. The thing is, this is such a high tension, the timing, as Amy was talking about before, this sort of rapid change. And then as Nick was referring to as well, as we're going to keep having these changes. It's not like climate has changed. It's not like the fishing industry has adapted to its new normal, even with the way the lobster resource and all of the other challenges it has, like right now. Again, the working waterfront issue from the January storms, gauge increase, price increase on operating costs. There's a lot going on facing the fishery, so there's a lot moving. And I think looking at static data sources is also going to be a problem going forward. We're never going to come up with solutions if we can't come up with a teamwork approach to understanding dynamic decision making.
Nick, I want to just ask you about the computational fix. So Nick worked on an algorithm that he and his colleague, I think she was a PhD student, trained to figure out when there was going to be an algal bloom in the Gulf of Maine. And it worked. And the industry's using it now, right? And DMR is using it.
Sort of, yeah. That's not exactly right, but
well, my real question is, can you predict where forage food and whales and all these other variables and fishermen and gear, how dynamic can science and data get us in terms of a response?
yeah,
Just in fantasy world, never.
right, yeah. No, that's right. And I think like I think you phrased it as a technological fix or something like
Yes, I
that.
did.
I view it as part of the conversation that Carla just described. Like, it's the environment's changing so much, the social environment's changing a lot, everything's changing, and we do need to be thinking about how things are changing and where we're going in the future, not what these sort of patterns have looked like in the past.
Mm-hmm.
And I think predictive modeling is part of that conversation. But it has its bounds, just like monitoring itself has its bounds, just like looking at our own historical perspectives have their boundaries. And that kind of conversation is required there's this process called foresighting, which is a little bit like forecasting, but where you kind of have that broader dialogue, multidisciplinary, bringing lots of people's experience together and just try to imagine, well, what are the different scenarios we could be looking at in the coming years and months and decades and so on. So I think like that's the bigger context. And then predictive modeling is I think a cool tool in the toolbox, and that's what we try to do at our forecasting center. So yeah, we have a whole range of models. Let's see if I can do this. I put just one example of like what a computer model might look like. And this is one from a few years ago where we were just trying to dynamically map the whale food resource. So this is just kind of a like running loop of it. The oscillations you see are the tides. So there's like 2 cycles per day, just to give you a sense of the time scale. And it's just looping through like a few days of the copepod resource in the Gulf of Maine. So just to give you a sense of how complex it can be. I can't even remember what month and year this particular one is from. But yeah, so we're looking at time scales of days, weeks, and months. We're looking at predictive models that can look out over many years and many decades. And then we're working with other collaborators and DMR as well to see like which of these models will help inform decision making the best. And there's big spatial scales and there's small spatial scales, and there's all these different, like with machine learning, there's all these different new approaches as well. So yeah, there's no one size fits all. Like you're not going to ask ChatGPT where are the whales going to be next month. You could do that. I actually have done that. I've asked it all kinds of forecasting questions and competed it against humans, and it does a lot worse than even the least well-informed humans. Just keep that in mind. But yeah, so there are all these predictive models that I think go into the conversations that like Carla described, and like Aaron is trying to, and DMR is trying to get new data to fill in those uncertainty gaps that have been so frustrating to all parties involved. And yeah, and I think forecasting, thinking ahead, both in terms of the dialogue, but also these cool computational models will help us do a better job in this like really rapidly changing environment that we're in now.
Now, I was pretty directed with this conversation at times because I wanted to get everybody's perspective in. Jerry Bowers has a question, I know, and I want to make sure everybody gets the last chance to make a point that they might feel that they didn't get to. But Jerry, what's go ahead?
Sure, other people do, but I just have a couple of questions. Amy, I'm just curious, is it possible to microchip whales or put some sort of GPS kind of tracking device on them?
There's, yes, well, there's a lot of interest in tagging right whales. Unfortunately, right whales treat any sort of foreign body like a splinter. And so tags don't stay in long. Back in the era when that first started in the late 80s, early 90s, the technology was really pretty poor, and a lot of the tags didn't transmit any data. They got better with the deployment and implantation. The duration lasted longer as the years went on, but still the electronics weren't working as well. So they've made some progress on that, but tagging also is quite expensive, and also really hard to get the tags to stay in long enough to be a helpful tool. So we don't feel like that's necessarily the best approach. I feel like our thinking is to think about how to make the fishing gear safer for whales. And I think that includes both the on-demand gear that Carla and Aaron have talked about, but also the weaker ropes that have been implemented to some degree in the fisheries. It's what we did a paper research study that published in 2016, looking at ropes retrieved from large whales and looking at the rope strength. And we showed that the smaller whales just weren't able to get free from those stronger ropes. And I think I might have mentioned this earlier, we recommended the 1,700-pound rope strength be used to help ensure that a whale could get free from the gear. And that has been implemented in Massachusetts. It's been implemented throughout the end line in state waters every 60 feet. So that, and it's hard to know if it's successful, because if it's successful, ideally you don't see an entangled whale. So that's always a conundrum with some of these changes. But I think the fishermen are trying to adapt to using that kind of weak rope in their fishery. And I hope that can be broadened up the coast to sort of be used throughout the end line to help ensure that if a whale meanders into the near shore waters of Maine, that ideally any entanglement that occurs is not going to cause lethal injuries. So that's that. And then the on-demand situation is expensive. There's lots of great trials, and but in my opinion, if we start focusing on using that in the offshore waters where they can't use the weaker ropes effectively because of how they fish and how much sea state they deal with, and all sorts of things affect that. Maybe that's one way forward for a broader management-based effort that just helps ensure every set of fishing gear is safer for whales. And if we can make that happen here in the States and in Canada, it could be a worldwide change, because entanglements are happening for large whales everywhere around the world. It's become a huge threat. You see it in the news every day. An entangled whale was disentangled at great risk to the humans involved, and sometimes leading to death. So my hope is that we can keep the dialogue going with the fishing industry. As you mentioned, that they weren't necessarily brought along during the process, and I do think that needs to improve to sort of keep them engaged and help them understand what we're seeing in the whales and help them understand how they fish their gear, so that we can ideally work together in implementing broader based solutions. So, yes.
Jerry, did you have another question? Do we have? Okay. Anybody here? Please.
But you touched on it a little bit. What is the international impact of all this? We're just looking at a small piece of the coast of the United States and Canada.
Yeah.
Are some countries still hunting whales?
The question is, say for the Zoom audience, the question is about the international picture for these animals? Are other countries allowing them to be hunted? What is the, the global population picture for the right whales?
Yeah, so the hunting of whales is really very limited these days. I think Japan is starting to hunt again. It was sort of a moratorium on hunting of whales for a while. Some countries are getting back into it, but in very limited, hopefully, degree. Right whales have certainly not been hunted since the 1930s, and I don't think any endangered species would be allowed to be hunted. Bowheads are hunted off Alaska, but usually like one every few years for a subsistence harvest. So I don't think that's a big threat, but the entanglement threat is huge. And I think countries are really looking to the US and Canada here on the East Coast to see how they manage, because we're dealing with a critically endangered species. Governments are required to address this threat. If we can fix it here and help this species recover, I think it will be a huge game changer worldwide.
There was a gentleman in back with a question. Yes, sir. Have you heard that? Ma'am, excuse me.
Sorry. I had a question. If there are any concerns with the speed of the implementation of policy versus the speed of the change we're seeing in the species? So say there's more of a presence in one area, and then there are adjustments in like shipping activity, fishing. If by the time some of that's implemented, the species is shifted again, if that makes sense.
I'm sorry, I didn't
So-
catch that. Can someone repeat that
I
question?
can repeat it. It was a question of whether the implementation of policy can keep up with changes in whale distributions. It's a challenge. Canada actually has a very different way of managing their fisheries and shipping. They can put in emergency measures quite quickly and have done so since the unusual mortality event. The US has a very different regulatory process. It's quite a bit slower and, in my opinion, quite clunky. They can put in emergency measures, but they have not done so yet. So it's a question mark is whether we can keep up. I think we haven't done a great job doing so far. So
I think Carla Gunther wanted to.
Yeah, I was just going to add to that. The dynamics of the two fisheries between US and Canada are quite different in that we essentially have a lobster fishery year round. And as fishermen haul their traps out or set them back out for the beginning of their season, it's done over weeks or, whatever. So we have smaller vessels with much smaller deck space. And so in Canada, they have a season they're regulated by very short seasons. Most of those boats, if you look, you can tell which one's a Canadian boat versus a US boat because they're much bigger and wider. And that's so they can get their gear out. They also have much different, municipally and other state invested infrastructure to support stacking all those traps so that they can get right out in a day's set. We're not set up to say whales are in the area. Okay, lobster fishery, bring all your gear home. And that would be a huge change to almost every way we're currently doing business. So, if that's the solution, then that's the solution, but we need to know and figure out how to plan for that and what those impacts are. So I think that's where it all comes down to, because any solution right now has a major impact, and trying to make those decisions involve more than just the fishermen on the boat.
Well, I think I will call it a wrap at this point. Obviously, we could keep this conversation going for quite a while. And I invite you all to afterwards to try to grab people before they have to take off. Jerry?
For those of us who are not science scholars, thinking a little bit about the resources that you're providing to the community, where should we go to find good information about this topic for those who want more?
Thank you for that. That's part of our grant with NIFWIF is to put out some more videos, some 5 to 8 minute YouTube videos. How did we get here with a lot of the data sort of provided with the different researchers. I think NOAA has a great website that had a few things in. DMR is putting some stuff out, but honestly, the answer right now is it isn't in one good place. And we're trying to do that with our efforts. So look at the MCCF, coastalfisheries.org in the next few months.
And we'll put together some information around that. And if you want to email us or me, I can get that to you. I'm fbever@mdibl.org, or there's info@mdibl.org. So I think we can go on and just want to mention, first of all, the young woman who was mentioned here is Dr. Miller, who's running this research out of Vinyl Haven, or this engagement project out of Vinyl Haven, was a intern here at MDI Biolab for several years, and then worked here, I believe, also in the Jane Disney Laboratory. So, you know, it's great to, in any capacity, play a role in the continuous paying it forward of the scientific enterprise, whether it's doing molecular biology or large whale biology interactions with human beings. So we're really proud to have played a role in that. These science cafes will continue through the summer. On July 8th, we have the award-winning children's book creators, Haley and John Rocco, who will discuss their latest conservation-focused picture books. They have a connection with us because one of those books is about oxalotl, which is one of our favorite models for human biology and regeneration. That's Monday at 5 p.m. here in Marion Auditorium. Later that week is our family science night. Lots of science activities for people of all ages, featuring work presented by our summer undergraduate research fellows, who are a fantastic source of energy and intellectual engagement here on campus. So there's also ice cream. So that's Thursday, July 11th at 4 p.m. Just look in your emails, look around, you'll see posters for it. We'll hope to see you there. So thanks again to everyone. Thanks to Aaron Summers for joining from the Department of Marine Resources. Amy Knowlton from the New England Aquarium, Nick Record from the Bigelow Laboratory for Ocean Sciences, and Carly Gunther of the Maine Center for Coastal Fisheries. It's really great to have this conversation. Appreciate it.